And here we go for page 6. Okay, you don't have to do this. This is not on the final exam. But anybody who's planning on taking HL next year, you should be able to do this. So you want to practice this. Also, stuff like this could show up on the final exam at the end of the year. It could show up on the IB exam. So these are good skills to keep in mind. Right, so given that 3 to the x squared minus 7 times 3 to the x minus 18 can be written as this. Okay, so that's factorizing. It can be factorized where a and b are integers. This means integers. It's kind of hard to read that. It's the letter Z. That means integers. So in other words, whole number is either positive or negative. Find the value of a and b. So we're talking about factorizing this. Now, this is a classic example where we can use u substitution. I'm going to let u be equal to 3 to the x. So if u is equal to 3 to the x, I can rewrite this in a much friendlier way. This is going to be u squared minus 7u minus 18. And then all of a sudden, oh my God, we know how to factorize this. So I'm going to factorize this. It's going to be u times u gives me u squared. Now I need two numbers that multiply to negative 18, but add to negative 7. That would be negative 9 and positive 2. Now I can substitute back in my u's, 3 to the x minus 9 times 3 to the x plus 2. And I was just looking for my a and my b. So a is negative 9, or could be 2, and b is equal to 2, or negative 9. So it doesn't matter which one's which. Doesn't say what order to put it in. Then, hence, find the exact solution of when this equals 0. So I already have it factored. 3 to the x minus 9 times 3 to the x plus 2 equals 0. Oh, by the way, this is a no calculator. This whole page is no calculator. Since it's already factored, I can now set each of these equal to 0 and solve them. So the first one, add 9 to both sides. I get 3 to the x equals 9. And hopefully you can just tell that x equals 2. If not, rewrite this with the same base. This would be 3 squared. Now that they have the same base, the exponents have to equal each other, so x equals 2. This one, minus 2 from both sides, I get 3 to the x equals negative 2. Now I want to raise 3 to some exponent and get a negative. That's impossible. That cannot happen. There's no way you can take a positive number, raise it to an exponent, and end up with a negative number. Doesn't work. So this one doesn't work, so there's only one solution to this problem. All right, simplify each of the following. There's no exponents on these parentheses, so I can drop the parentheses. Okay, and now I can rearrange it. Let's put the coefficients together. Let's put the m's together. And let's put the n's together. So I have 5 times 6 is 30. M times m squared would be m to the third. N to the 8th times n to the negative 3. I just add the exponents. I get n to the 5th. There's my answer. It's not necessary to show these intermediate steps. This can be done just in your head. It's quite simple. Okay, the next one, I do have power out of power, so I'm going to simplify that. So I have 2. Oh, and also, I don't like negative exponents. I'm going to move them. I'm going to move this down. I'm going to move this up. So I have 2, and I still have y to the 5th. It is a 5, right? And this is y to the negative 3. When it moves up, the exponent changes its sign. And on the bottom, I have x to the third, because I moved this one down to make it positive. And then I still have this. I'm going to go ahead and write this out twice. This is 4x cubed times 4x cubed. Because the 2 is on the parentheses, so the parentheses are being repeated. Okay, now I can go ahead and simplify some stuff. 2 over 4, that's 1, and that becomes a 2. I just broke my lead. On top, I have y to the 8th. And on the bottom, I have 2 times 4 is 8. And then I have x to the third times x to the third times x to the third. That would give me x to the, there's 3, 6, 9 of them. So y to the 8th over 8x to the 9th. Okay, the last one I need to distribute. When I multiply these together, I have to add the bases. So actually, I'm gonna put them next to each other so you can see what I'm talking about. So x to the 1/2 times x to the 1/2 minus 2 times x to the 1/2 times x to the, what is that, 3/2? Plus 3 times x to the 1/2 times x to the -1/2. Okay, so our rule, when we're multiplying like bases, we add the exponents. Okay, right? Like over here, m to the first times m squared, m to the first times m squared, we add the exponents. N to the 8th times n to the -3, we add the exponents. So same thing here. 1/2 plus 1/2 is 1. So we get x to the 1 minus 2 times 1/2 plus 3/2 is 4/2. 4 divided by 2 is 2. So this is x squared. The next one, x to the 1/2 plus -1/2 is 0. Okay, we can simplify this. I'm going to start with my highest level exponent. That would be this term, so -2x squared. And then my next one would be plus x. And then the one with the smallest exponent would be this one. X to the 0 is just equal to 1, so 3 times 1 is 3. There's that answer. Okay. The next one, if I want to solve this, the easiest way is going to be to rewrite these with the same base. So I can rewrite 1 over the square root of 2 as 2 to the -1/2. And then 4 to the 2x plus 1, I can rewrite that as 2 squared to the 2x plus 1. So I just changed the 4 to a 2 squared, and I kept my exponent. And then this one, we're kind of used to doing that with our calculus now. Now they have the same base, so I can set the exponents equal to each other. Okay, so I am going to solve that. I'm going to let you take it from there. Okay, I did the hard part. All right, this one, same thing, 5 to the x plus 3. This can be rewritten as a power of 5. This is 1 over 5 to the 3rd, which is 5 to the -3, and then I can set the exponents equal to each other, and I'll let you take it from there. Okay, the last one, we first need to find the inverse function of f of x. So the way we do that, y equals square root of x. We switch the x and the y, so x equals the square root of y, and now we resolve for y, so I'm going to square both sides. So I get y is equal to x squared. Okay, so that is my f to the -1 of x is equal to x squared. That's the inverse function. So it says put g of x into the inverse function. So here's my g of x, so I'm going to put that in here. So I'm going to have this part right here is going to be, what did I just say? I'm doing g of x into here. So 2 to the x squared is equal to 0.25. So I have a power on a power, so I can rewrite this as 2 to the 2x is equal to 0.25. Again, I want to rewrite this as a power of 2, so 0.25 is the same as 1/4. So 2 to the 2x is the same as 1/4. 1/4 I can rewrite as 1 over 2 squared. So 2 to the 2x is equal to 2 to the -2. Now I can set my exponents equal to each other and finish that up. I'll let you finish it. All right, that's it. Finish the packet.